So a few more of these problems as examples. And again, the focus isn't how to do this particular problem or that particular problem. It's the recipe, it's the process. It's focusing on the facts you know, on the theories and rules you know, and the definitions you're supposed to know to make the problem progressively simpler until it becomes as simple as it gets. So our first problem, we got 4 over x plus 7 over y. And that whole thing is over come on. 7x plus 4y. Okay, brand new problem, never seen it before, but you have the tools to deal with it. So let's think, what's the first tool do you think we're going to look at? What's the first thing we're going to look at? First thing we're going to try to unpack here. Okay, what's usually been in these problems the first thing we try to sort of unpack to deal with? The first piece of this that we try to mess with. The division bar, right? The division bar and its 2 meanings. Okay? So those 2 meanings are, again, it's division and grouping. So somebody tell me what to write. I'm going to start with the easy part. Parenthesis. Go. 4 over x plus 7 over y. The numerator is grouped together, and the denominator is grouped together. And what goes in between these? Division sign. Okay. People looked at me like I was from the moon when I was suggesting this here. It's just, yeah, those are the 2 things we know. That makes things more simple. Okay, so now we start messing with things inside the parentheses as much as we can. So how can we make this a little bit better? To get common denominator. So how do I get a common denominator? Well, let's look at this first fraction. What do I do to it? We multiply it by y over y, and I love how you phrase that. Okay? It's not just multiply by y, because that changes it. But multiplying it by y over y is multiplying by 1. That's okay. And what do we do with the second fraction? X over x. And so now what we have is 4y plus 7x over xy divided by 7x plus 4y. Now there's nothing we can really do to combine 7x and 4y. Okay? Now, so we've got this division problem. What's usually the next step we do once we've got it down to this point where it's as simple as of a division problem as we can go? Then what do? It involves division. It involves fractions. What do we usually do? Flip a fraction. Now this thing isn't phrased as a fraction. But anything can be phrased as a fraction. Simply put it over 1. So even an integer or a nice 1-level expression can be phrased as a fraction by putting it over 1. Dividing by 1 leaves something unchanged. So now what we've got is over on the left side here, 4x plus, or 4y, excuse me, plus 7x over xy And let me just erase this for a second. There's a little stray mark. 4y plus 7x over xy. What do I write next? What right here? Multiplication symbol times what? Times what? 1 over, oopsie, it's 7x plus 4y. Now what can we do? Again, division is always multiplication by the reciprocal. We invert and multiply. So 7x plus 4y over 1 becomes 1 over 7x plus 4y. There's something we can do. It may not be real obvious here. Is there any canceling we can do? Is 4y a factor? So somebody in the class here suggested 4y. Is 4y a factor? No. This expression down here is not equal to 4y times something. So 4y is not a factor, and 4y can't be canceled. The thing that maybe makes it hard to see is, look closely. This is 4y and 7x added together. This is also 4y and 7x added together. Commutative property. We can just swap the order these two things come in. So these two things really are the same. We weren't able to do that when it was a minus sign between them, because something like 3 minus 5 is not the same as 5 minus 3. But commutative property works with addition, right? 4x plus 7y, or 4y plus 7x is the same as 7x plus 4y. We just swapped the order where these came from when they wrote this. So these two things cancel. And we are left with 1 over xy. Now, are we done? Well, are there any common factors in the numerator and denominator that can be canceled? No. We're done. Let's take a look at number 6. Okay, so number 6, to clear off a screen here for us to work on. I've got y squared minus 25 over 5y. Y squared plus 5y over 4y cubed. I will mention I can think of a couple ways to do this. There's more than one way to go about this particular expression. But I'm going to suggest, since we've had this kind of rhythm on most of the problems of approaching it, of unpacking it, that we just use the approach we've been using on most of the problems. So what's the first thing we've been doing in terms of re-expressing these complex fractions? It's grouping. Well, the grouping's already done because there isn't multiple sides, and re-expressing it as a division problem, right? So I've got y squared minus 25 over 5y divided by y squared plus 5y over 4y cubed. What can I do next? Again, pretty standard. What have we always done next when we've got a division sign here? Okay, folks in this room, please pay attention, because this is hard stuff, and there's people kind of looking at wherever, and then they're going to bug me later on. Okay, what do we do after division? What have we done on every single problem after we've gotten to the point where it's a divided by? Change it to multiplication. So I've got y squared minus 25 over 5y times what? 4y cubed. We got to invert the second fraction or get the reciprocal of the second expression. It's the same thing we've done every other time. Now, usually this is the point where we cancel, right? But to cancel, what do we got to do first? To understand what we can cancel, what we can't cancel, what have we got to do first in this problem that not all the other problems had? Factoring, yeah. We've got to re-express, so y squared minus 25 becomes what? Y plus 5, y minus 5. There we go, the difference of squares pattern. This is y squared minus 5 squared, so it becomes y plus 5 times y minus 5. 5y, not much we can do with that. 4y cubed, not much we can do with that. Y squared plus 5y, what can that become? Y times the quantity y plus 5. Okay, so what should we do next? The y plus 5s can go away. We know they're going to end up ultimately on the top and bottom numerator and denominator of the same fraction. So they can go. What else can go? Yeah, which y? This y can go, and this becomes what? Y squared. What else can go? This other y is going to ultimately end up on the bottom of the same fraction, so it can go, and this becomes 4y. And so let me select this all out. Give us some more room to work with. Okay. And what we've got then is y minus 5 times 4. I usually like the constant term first. That's our numerator. And 5 is all that's left in the denominator. Again, can the 5s cancel? No, because 5 is a factor down here, but it's not a factor up top. The top cannot be expressed as 5 times something. Yes, there is, right? Yeah, 4y times y minus 5. Thank you. I missed that. That's the problem when you get real too messy canceling like this. You'll miss sometimes factors that you still have there amidst the wave of slashes. So be careful. 4y times y minus 5 over 5. Okay. Let's talk about 7. Ooh, nasty looking, but it's the same thing. I want to look at 8. Nasty looking, but it's the same thing in a lot of ways as number 5 was. So 7 and 8, I don't think we need to go over. I think your time is better spent working. So that's where we will leave it, is ending there.